what will happen if you don't assign responsibility? What will happen if you don't assign responsibility? It is, this thing need to be done. Then you don't actually assign responsibility, then what will happen?
It won't get done, or you won't have anybody to blame.
Exactly. You don't have anybody to blame and nothing will get done. Okay? That's why I don't want you guys to do team projects. Right? I don't, at this stage, I don't want to spend time to arbitrate between two fighting team members. Right? Actually, I think that at this stage, I mean, you all need this level of technical development. Okay? I mean, so if you look at our capstone project and other projects, there are always, some people do a lot of work, some people do little, right? They're always, I mean, in reality, that it's the same thing. So that's why capstone project lets you go through that is nice. But on this stage, I mean, 300 level, yeah, you got to do your own work. And that's my belief at least. All right, realization means basically assign job responsibilities. How do we do that? We take a scenario, okay? Step by step, when we take a scenario, we overlay this, take a scenario and put it on the class diagram. Okay? We take the step by step from the scenario. Then we say, okay, who will take step 1? Who will take step 2? Who will take step 3? And all the way to step 7, we need to put the blame on somebody. Straight and simple. This is a class. Your user can be as a class, just for simplification of the description. Basically, you are actually assign responsibilities to classes. That's it. Okay, you can see that there's no complicated thing in our business. This is a thing you've already been doing in your practice. You need to basically assign responsibilities. Who has led a team before, of any sort? Right? If you have led a team before, your job as a manager or a leader of the team, your main job is actually to assign responsibility and check that responsibility. Okay? That's your job here. Those are your minions. You need to assign responsibility to them and make sure they do the job. For instance, if I assign that responsibility, I say, okay, Jason, you are going to do user interface. I'm going to assign 1 to you. I'm going to assign 14 to you, because those are the messages sending to you. Sending a message to you means that I want you to do something. Okay? So I'm an architect. You are a programmer. This is how we work. Come on over, Jason, you need to do this. Okay? You are receiving a request. Then you have to send out reply, transfer request to somebody, and get reply back. I have the interface loud and clear here for you. Okay? This is your job. Then I hand over this class to you and say, go implement. You already learned in Calafon class, be able to do this 200 line of code. This is 200 line of code, go do it. Okay? When you come back, I'm actually going to use this, exactly the same thing, to check whether you are able to do it or not. If you're able to do this, great, you did your job. And also to me, because you did this, I'm actually can plug your implementation into the system. Guess what? The system will be assembled together and work. This is how we scale up from a bunch of minions like you guys into a real development team. No other magic formula. This is how it happens in real life. This is exactly what happened in real life. Because most companies, when they hire you guys are actually responsible for one of these. That's your job. Go do it. I gave you the interface. This is a message you need to consume. This is a message you have to send back. You go work on logic. That's it. I'm assigning the job to you. You'll be doing that. That is how this is called, actually this is process I just described is actually called software engineering. Once I get to this level, basically I know, okay, I can hand over to one of you guys, you do the job, come back. If you match the interface, the system should work. If it's not working, my bad. As an architect, I failed, right? If I actually follow the right design process we have described before, then I should succeed. If I succeed in terms of design, I assign it to you to implement, you succeed, guess what? We have a system. Whether that system is the best optimized system or not, I don't know. That is actually our experience and more learning and more doing. But whether it's going to be a system running, yes, this process will guarantee you to have a system that is running. All right, guys, are we clear on this one? If you run all the scenario like this, basically you're going to take care of all possible messages going to a class, all possible messages going out of a class. That is essentially your definition for your tree. Then I can actually hand that tree class to you to implement and plug that into my system. Guess what? It works. Because we have a clear defined interface, which I'm going to call your object, you're going to provide the service. And this is also a glorified model of Amazon AWS. Amazon Web Services, same thing. Same thing. They actually exactly use this diagram. You'll see many diagrams on Amazon website teach you how to do it. You send a message to a service to get some information back. That's it. That's your interface. That is called web services. Web services is just a glorified term of calling a service not here but on the web. Here, this service is local in your own class. All right, programming concept is pretty easy. Okay, all these hooplas about TensorFlows and SQL database, I mean, the reason is to do things more efficiently, more scalable way, but fundamentally they are not the core. The core thing is our programming. Okay, SQL basically means what? I send the query to the database. This database is super complex, which is actually called, there's something called Oracle, basically, is that database, okay? Or Google's database, right? I mean, Oracle actually have 10,000 people working on that database, right? But to you, it's only an interface. You send a message, you get a message back. To carry is implemented by 10,000 people as a very efficient engine, or it's implemented in a very inefficient linked list like what you guys did? Probably not, as long as the performance matches the requirement. That is the power of interface. That is also how we actually scale up a software system. All right, you do this a lot of time, using this. So essentially, this is how you actually look here. I'm not going to detail about these. These are essentially you are assigning responsibilities to objects. Okay? All these assignments of responsibility. Another one. So essentially, you can see that you can actually, this is a sequence diagram. Same as the collaboration diagram, just that the focus is on looking at a sequence of messages, not how the system works together. Let's look at the difference between these two. This one shows you how these objects collaborate with each other, who talk to whom, right? You are actually pretty object-centric, okay? And here, the object is a square in the middle. Right now, if you look at sequence diagram, you actually put the premium on the sequencing information on how this scenario actually happened. Same thing from different angles. Actually, in commercial tool, push a button, you generate this diagram from each other. Very easy. But they carry the same information. There are no loss of information here. The information is there. Just that one is focusing on classes. What's their single class responsibility? This is more on how this actually the whole scenario pans out. Okay? All right. So essentially, you can do the same thing for different scenario. Again, you got your class diagram. You assign responsibility. You can do the sequence diagram to look at how this scenario actually happens. Same thing. Same thing for another use case. All the scenarios, you realize use case, you realize all the scenario, right? Then you can decide whether you're going to update your interface or not. That's up to you. Again, use case diagram, class diagram, overlay your use case scenario, then you are assigning more responsibility. If you're done with all the use cases, all the scenarios, then you have assigned all the responsibilities. Then it's time, this is the time we can actually move into detailed design. In terms of detailed design, I actually have your class attributes defined and your class operation defined. And now that's the handover from your architect to your designers. Okay? Can't be the same person, right? Just conceptual-wise, we are moving into the system in terms of use case diagram into high-level analysis by identifying classes. Now, as we assign all the responsibilities to all these classes, and now once we talk about detailed design, we are moving into each class. Okay? Once we move into each class, we have their algorithm picked, then it's going to be implementation. All right? So you repeat this, until all your use cases are realized. Then you got your final class diagram. That's it. So all the information you stabilize, then you're ready to implement. So essentially, scenario is a specific execution sequence. Okay, use case is actually a group of scenarios, right? So it's not just use case, just one key one feature, and your scenario are different ways of using the same feature. Using it wrong, using it correctly. All right. So I'm going to stop here and let you read the rest of this. But the keys, just to recap, the core thing for us in analysis, also called high-level design, is to find out what are the classes in your system. Right? We can do that by a non-analysis to find out the permanent information we need to store in the system. If non-representing some information not necessary to store in my system, then non is put on the backup list just to be there. Okay? Then we do our dynamic analysis to see the high-level behavior and workflow of our system. Then we start assign responsibility by realizing our use case scenarios on top of our classes, by assigning all the responsibilities to these classes. Once you do that, you're ready to move into each individual classes. That is really the detailed design. That is really almost close to what you guys have been learning in lower level classes. This is also the interface, as I mentioned, how we scale up a software engineering team. Okay, well, that's how a company, a team, can take people like you guys just graduated and can have a software engineering project going. That's exactly what happens. As you learn more, you got promoted to designers, architect, and so forth. Then your job becomes figuring out the requirement by identifying the use cases, identifying the component of your systems, assign responsibility to these classes. Then you can give the job to somebody else who just joined the team. That's how you have a software development engineer level 1, software development engineer level 2, senior software engineers, principal software engineers, and so forth. Okay? That's just that job hierarchy, very similar to our class hierarchy. Okay? If your job is dishing out all the work, you got paid more. If your job is to do the most minimum low-level work, you got paid less. That's how it works in our industry. Right? Why? Because if you are dishing out the work, for instance, you are assigning the job responsibility to these classes, basically what means that you are capable of taking care of a bigger size system. Instead of taking care of one class, you are taking care of a subsystem which is composed of 20 classes. Should you get paid more? Yeah. Because you are responsible for maybe, if for each class a 50 line of code, you are actually responsible for 1,000 line of code, and the other guy responsible for 50 line of code. Should you get paid more? Yeah. Because you have the experience and capability to do that. Naturally, that's how it works. Okay, that's how we organize a software engineering team anyway. Okay? All right, so I'm going to just kickstart next chapter, the detailed design, so that we can have a good transition here. Design in this case is actually what we call detailed design. We are actually walk right into an object, a class. Okay? So here we are going to look at a different way of doing this design. I mean, this is a little bit history about how we deal with design. You can see that we have operation-oriented design, we have data-oriented design. Essentially, you can see that no matter where you go, there are just two things, either operation or data. No exceptions. No exception whatsoever. Data and the operation you can conduct on the data. Nothing else should be in your system because that's waste your time. That's waste your time. All right. Just two aspects. Data on the actions that operate on data on which the operation operate. No exception. Okay. Think about your system that way. Make your design a lot easier. What kind of data you have in your chat app? User registration information. These things are typically one-time thing, right? They just register once, and it's going to be there. The other thing is your chat history. Nothing more for your chat app. What else do you need to keep? No, that's it. That's the data you need to save. Whenever once I register my name with your system, I should be able to go back to your system. Once I talked on your system to somebody, I should be able to retrieve that information back. Plain and simple. That's the data you have on your system. What operation you need to consider? Yeah, your system need to consider how to collect my registration. That's action. How to store my registration. How to retrieve my registration so I can log in. How do I send out a message? How do I receive a message? As a group, individually. That's it. Okay? Full coverage. That's how you can tell. How we scale up to a bigger project like Facebook, yeah, you partition into manageable sizes and give to somebody to work on. That's it. That's how we scale up. That's how, actually, also how you scale up your capability of developing software. You do the same. You take a project, partition them into manageable size module, which you are comfortable with already. then you can do the whole system. Same thing. Happen to be in your ability to scale up is your ability to partition work for yourself. You are partitioning a bigger size system into things that you can manage comfortably right now on your level. Right? That's why when we eat an apple, we take bite by bite, because our whole digestion system can only deal with that one single bite. Okay, what will happen if we put the whole apple in the mouth? First of all, you need to be able to put it in. I mean, so that's pretty tough, right? But once you put it in, you know what's going to happen. It's going to stay there. Okay? So that's not how you actually eat an apple. You either cut it with knife into pieces, you eat piece by piece, or you chew on, you bite on the apple bite by bite. Just that algorithm is pretty straightforward. You just bite, and then you're done. Here you need a little bit of thinking of partition your system into hierarchy. Okay? Same idea. If you have a team, your responsibility is not just to give yourself some work, you actually need to give somebody else some work. Right? That's the only difference. However, we know because it's not the same person anymore, then you have communication overhead. Then you need to write documents. Right? If you don't read the document, which means that whenever he needs something to implement, he needs to come to you and say, what do I do with this? That's what you don't like. That's why you give him, go away with my document. That's pretty much it. Why we write document? Is to make the other guy go away so he doesn't come back to you. So that they can independently work on this thing themselves. Right? This is how you actually can scale up work. If your way of working is always like, okay, whenever he needs to do something, he needs to talk to you.